Today we'll explore the parametric equations of an ellipse and understand how they describe this beautiful curve. The parametric equations are x equals a times cosine theta and y equals b times sine theta. Let's visualize how these equations work. We'll start with a coordinate system. First, imagine a point moving around a circle with radius 1. This is described by cosine theta and sine theta. Now, when we multiply cosine theta by a and sine theta by b, we're essentially stretching or compressing the circle horizontally by a factor of a and vertically by a factor of b. The parameter a determines the width of the ellipse, while b determines its height. Let's derive the standard form equation of the ellipse from these parametric equations. First, let's square both equations. Then divide each equation by a squared and b squared respectively. When we add these equations together, we get the familiar standard form x squared over a squared plus y squared over b squared equals 1. Now, let's find some specific points on our ellipse. When theta is 0, cosine is 1, and sine is 0, giving us the point a, 0. When theta is 90 degrees, or pi over 2 radians, cosine is 0 and sine is 1, giving us 0, b. We can find any point on the ellipse by plugging in different values of theta. To summarize, the parametric equations x equals a cosine theta and y equals b sine theta describe an ellipse by stretching a circle horizontally by a and vertically by b. These equations can be converted to the standard form, and any point on the ellipse can be found by choosing a value for theta.